Welcome to CAB Builder online training series. This video will tackle the second part of the construction global options by making a cabinet construction method. We've told CAB Builder how to build drawer boxes and join their parts. The third submodule, Construction Cabinet, will do the same except for the cabinet box and its elements. The layout of this module almost mirrors the drawer box counterpart. Available construction methods are shown at the top left of the screen. Selecting a construction method shows its options in the middle. Actively selected options have their attributes listed in the rightmost column. And finally, the bottom left of the screen has construction styles, enabling users to tweak constructions between cabinet types. Just like before, you are given templates for consistent starting points, one for framed boxes and another for frameless. These two construction types are the same, except framed constructions have an additional face frame options that also can interact with different elements. The templates are read-only and marked with a lock label, so click on Create to make your own. Click on the drop-down list to select which type of method you would like to create, either framed or frameless construction. Enter the name of this new construction and then click Create. Now let's take the method apart piece by piece. The first section is called Preferences. Their impact is twofold, most important of which is determining the default part types for elements within your cabinets. For example, let's define the default side construction as finished side. If we check back to a cabinet's wireframe with this construction method applied, we can see that the side will, by default, be a finished side unless otherwise specified by the user. It is recommended that you set these preferences to the most common configuration in your cabinetry. This will get the most amount of work done globally before you then have to change individual cabinets' wireframes. The secondary effect has to do with the default shelf and partition constructions. Not only do these control existing shelves and partition in default cabinets, but they determine the default type adopted by a new element within the inside sections menu. For example, if I set the default shelf construction to adjustable shelves and I go to the inside sections within a default cabinet's wireframe, new added shelves will have adjustable shelf as their default type. Next, we tackle door overlays. The first parameter defines the overlay type: standard, full inset, custom inset, or custom reveal. The chosen type determines which reveal settings come into play from the next subsection. Let us look at each of these behaviors in action. Standard overlay will create a single overlay value all around the door and drawer front. Going to the attributes of our corresponding door verifies this selection. Half an inch overlay all around. The next two solutions deal with inset doors and drawer fronts. Inset is calculated from the back of the closed door to the front of the cabinet. Full inset minimizes this value, making doors and fronts flush with the front of the cabinet. For other inset values, custom inset must be selected and specified. Clearances between inset doors and the opening are drawn from the door tolerance parameter. For example, let's specify a full inset, which will send 3/4 inch deep doors inside the cabinet by the full 3/4 inch. The 1/16 tolerance makes the door 1/16 less than the opening in all four directions. The last option, called Custom Reveals, enables reveal settings for default calculations. These cover door and drawer front reveal situations piece by piece. A special note must be taken of differences between paired and non-paired doors. Paired doors are identified by two opposing doors of the same size and no mid-stile between them. Doors or fronts that do not fit these requirements are deemed not paired. There are times when default overlay style cannot be used in a situation. When this happens, CAB Builder will use the appropriate reveal settings instead. For example, selecting a standard overlay for a construction method will have the aforementioned overlay value all around the doors area. But what happens if we delete a mid-stile between two doors? By definition, overlay calculations need frame part widths. Such situations call for the relevant reveal setting to take over. For example, reveal settings dictate that the vertical reveal is 1/4 inch between two doors. The same thing happens when changing the inset adjustment for a door. Overlay calculations no longer apply and the door tolerance inset setting takes over for the door size. The wireframe system gives you the flexibility to adjust an element in and out of the construction defaults, so it is recommended that all reveal settings are taken care of for such situations. The next section deals with general frame settings. The first parameter is called Default Frame Thickness. This parameter type is common, and it works in the same way as it did in the drawer box construction method, as an expected nominal thickness. The other frame part settings are self-explanatory, also with a few more parameters for blind corner cabinet special cases. Users must then tackle side case part constructions in the next section. There are different side types, so let's get familiar with them. Finished and unfinished sides are single-piece side constructions that can be found in most cabinet techniques. Side panels are panels applied onto the outside of an inner case part. Whenever a side is made of two panels, the inner part is called subside, and it can appear in other types such as side-applied doors and subsides. Going back to the options, we can see some more common construction parameters: default part thickness, grain direction, banding, and side toe kick notch. These are self-explanatory except for the last. Side toe kick notch is active only when toe kicks are integrated into the side, this setting being found in a later stage. When active, the parameter determines if the side has a toe kick notch installed or if it is left as a full side panel. Unique parameters, such as scribes and offsets from other cabinet parts, can be seen for some of these side type constructions. The next part deals with the construction of back case parts. There are two types, finished and unfinished, and each of them have some common and some unique settings. Diagonal corner cabinets have clipped backs that also have their own special use parameters. Any back construction can be accompanied by back nailers, all configured in the back nailer subsection. Take note that if you add back nailers inside the cabinet's case, their thicknesses is not accounted for in the drawer box depth clearance parameter. This is something that we have seen in the past when making our drawer box construction method. Cabinet top setup is up next. There are 5 top constructions: no top, full top, stretchers, web frames, or gussets. Choose which applies in the construction type. But what if you need the same construction method to create different top types for different cabinet classes? I.e., what if you want base cabinets to have gussets while all others will have a top? The answer is construction overrides, and they can be found in the lower left hand of the screen. Overrides will be listed under construction styles. There will always be a default style, and it represents the set of construction options active for all cabinets, unless overridden by another. Create an override by clicking on the gear and enabling the appropriate checkbox. In this case, we will enable an override for base cabinets. When the checkbox is active, the style is activated. This new style is a real-time copy of the default except for the overridden options. So first, click on the default style to make it active. Go to the top construction type and enable full top. Then select the base cabinet override. Go to the top construction type and change it to gussets. Notice this changed the font of the option to bold and italics. This is to mark the difference between override and default. You will also see a reset to default button, which reverts the option back to the corresponding default. The result is that this construction method will apply gussets to all base cabinets and full tops to every other cabinet type. Continue with the rest of the construction method within the default style and switch to an override when appropriate. The rest of the top construction category deals with the top sizes, positions, banding, and grain orientations. The bottom construction section is fairly straightforward: thickness, position, material orientation, and banding. The unique bottom construction setting determines which cabinets get a bottom panel. All of them, none of them, or all of them except for cabinets with a bottom drawer. Toe kick settings will instruct CABuilder how and where to apply toe kick constructions. The first option chooses what type of toe kick is used: toe kick, legs, both, or none. Choosing toe kick will utilize separate toe or integrated toe kicks depending on the following settings. Legs will replace toe kick constructions unless the user chooses both. Assigning none will remove both legs and toe kicks and make the default base cabinet construction go all the way to the ground. Thickness and toe kick height determine the default dimensions of generated toe kicks. When toe kick is enabled in a situation, it can be either as a separate toe or integrated into the sides. Default form is set in the toe kick assembly. One may also elect to leave the toe kick out of the overall cabinet height. This can be useful for some who utilize separate toe kick constructions. The final general toe option is toe kick sleepers. Its purpose is to add structural stability to cabinets of greater width than normal. Users may enable them at an interval or disable altogether. Front, side, and back toe kick sections determine the existence, recess, and banding of the relevant toe parts. Leg positioning, when applicable, will follow parameters set in the leg section. There are 3 general shelf element types in CABuilder: simple, shelf, and adjustable. The first of these is the simple shelf. Simple shelves are general shelf elements that one uses to hold objects within a cabinet. It can be made up of 3 sub-elements: nailer, shelf board, and bullnose, the latter 2 being guided by the simple shelf settings. Their nominal thicknesses, adjustments, existings, alignments, grain direction, and banding are very straightforward. Fixed shelves are very much like simple shelves, except they are expected to be used for more load-bearing purposes, such as separating two openings inside a tall cabinet. They have settings of the simple shelf, plus an additional one called position related to frame rail. This allows fixed shelves to automatically move flush to, or some custom offset from, the edge of some overlapping frame rail, making them ideal for use as secondary bottom panels. Adjustable shelves are much like simple shelves, except they are meant to be used with pinhole drilling, making them easily adjustable with pins. They have the same construction settings as the simple shelf. Simple and fixed shelves may have nailers for additional support. Specify the dimensions of these, when they get applied, and their banding. Drawer stretchers are often used in frameless constructions for their cabinet top support. Tell CapBuilder their dimensions, where they are added, and their banding. There are two base partition types, partition and divider. Partitions are intended to be used as divisions between adjacent drawers, providing support and mounting points for the runners. They may also be used to separate openings in multi-chamber cabinets. Specify the nominal dimensions, grain direction, banding, and default adjustment from the front. You can also tell CapBuilder to automatically add drawer partitions between adjacent drawer boxes. Dividers are to partitions, like simple shelves are to fixed shelves, because they are generally intended to be visible on the side. They have the same options as the partitions, except for one. Either of these elements may come in double constructions, where two dividers or partitions are put together back to back. Internal styles tackle the task of offsetting drawer guides enough to clear doors and their hinges, useful for rollout shelves and trays. Each internal style pair is made of the main internal style and its support. A cabinet side may be furnished with a single pair or two pairs, depending on whether the drawer guide needs one or 2 points of contact. The construction method determines the default construction, how many pairs per side, inclusion or exclusion of supports, widths, thicknesses, bandings, and positions. With the cabinet's boxes constructions done, the next step is the joint section. This may look like an expensive set of options, and it is, but it works in the same logic as seen in the drawer box construction method. Once again, every permutation of every connection must be specified. The more potentially touching elements available, the exponentially larger the list. Fortunately, this list is split into sections depending on what elements are being joined. Face frame joints handles joints between frame parts. Face frame to case joints goes over connections between frame parts and sides, bottom, or top constructions. Side to back construction joints are under case joints. Top and bottom joints have connections between top or bottoms and side or back connections. Toe kick to case joints has connections between separate toe kick parts and back to side connections. These separate toe parts can be connected to each other as well, so their joints are specified under toe kick joints. Any connections involving internal elements are found in the last subsection called internal joints. It is organized by the type of internal part to be connected. Knowing this general order makes it easy to navigate directly to the relevant option. For instance, I want to connect my simple shelf to my sides with a dado. Since the shelf is an inside element, I expand the internal joints section. Simple shelf joints are under the simple shelf subsection, and now I am exactly where I want it to be. Organized or not, there are still many joints to be created, many of which can use the same connections in your shop. For example, maybe the frame parts are all connected to each other using butt joints. There is an easier way of handling this than just filing every single one of these connections. Enter the joint's default subsection. Their purpose is as the name implies, default connections that apply to the specified subconnection unless overridden by selection. Let's now place a butt joint in the face frame joint default. Going to the face frame joint subsection, we can see that the default shows up as expected. You may override this default as you do with any other joint, or you can set it back to the default in the default category of connections. Cabinet construction methods are built to accommodate a wide range of cabinet techniques. While the task may seem daunting, it goes by quickly when it is taken section by section and it is done by someone who knows their cabinet builds. Thank you, and I will see you in the next video.